Hi everyone, so we're going to continue our talk about big and huge stars here. So if we're looking at a new term here is a pulsar. So a pulsar is a rotating magnetized neutron star. And remember that a neutron star is going to be the result of a big star after its supernova. So it's these charged particles are accelerated at the neutron star magnetic poles. So not the actual poles of the star, but its magnetic poles that you can see here. And it produces two beams of radiation. Remember, radiation is kind of like light, and these beams act like a light from a lighthouse, and we're going to see an example of this. So we have our axis of the star, and then we also have our magnetized here. And what we see is that these beams of light come around like a lighthouse. So if you know what a lighthouse looks like, we know that these beams of light come around every once in a while to show these. So that would be what a pulsar is. So if we look at some radio rays, we can see the frequency is pretty consistent here with our pulsar. Though some brighter than others, more radiation is given off, but we see a pretty consistent intensity increase over time. So if we take a look at other different nebulas and pulsars, we see our Crab flashes and X-ray pulses are identical, have periods of 0.033 seconds. So we can see we have different on and off states, so we can see that extra radiation occurring here. Okay, so another thing we're going to talk about is collisions of neutron stars. So collisions of neutron stars can create heavier elements. So these collisions are going to create elements like gold, silver, platinum, and uranium. So our stars, this neutron star, these collision are going to make those heavy metals that you can see a lot in jewelry. It's also made from elements that are like carbon, oxygen, phosphorus, iron. All of these are going to be made from hydrogen. So when all of these collide and come together, all these different hydrogens, we're going to get heavier and heavier elements here. So we're going to talk a little bit about black holes now. So remember, black holes are going to be a result from huge stars after that supernova explosion that we can see here. So remember that these evolution of stars depend on their masses. So huge stars, after that supernova explosion, we're going to create a black hole. So looking at a summary here, so evolution of stars, again, depends on their masses. Stars like our sun will turn into a planetary nebula, and then to a white dwarf, and then to a black dwarf that give off no light. Our big stars that are between 8 and 25 solar masses are going to end up as neutron stars here. And then our huge stars that are over 25 solar masses are going to end up as black holes after our supernova explosion. Remember that these materials from old stars, our planetary nebula, and our supernova remnants get recycled, and these are going to form new stars. So stars are the ultimate recyclers. So remember, all of this material that is given off after this planetary nebula or supernova explosion is going to be used again to make new stars. So answering some of our questions from the beginning, how do stars form? We form from a mutual gravitational attraction between gas and dust inside giant molecular clouds. Are there stars forming today? So yes, astronomers see stars that have just arrived on our main sequence, and we can see different images of those. Do stars with a greater mass shine longer? Yes, right? Or not with a greater mass. So lower mass stars actually shine longer because it has a lower gravitational force inside that star. So it's able to last longer. We have slower rates of fusion inside. So we're going to see our lower mass stars last longer, though our greater mass stars are going to shine brighter. Will the sun someday cease to exist? Yes, so remember we looked at that. So our sun is going to eventually turn into a planetary nebula and then into a white dwarf. What are the origins of our heavier elements? They're created during stellar evolution and different supernova explosions and colliding neutron stars. What is a pulsar? It's that rotating star that looks like a lighthouse, so it's a magnetic field on our neutron star here. So just again, looking at stellar evolution, we have stars like our sun. So our sun is going to make a helium core. What's happening there is we see hydrogen core fusion, and this is going to last about 10 billion years. Then we'll turn into a red giant here, where we're going to have a hydrogen fusing shell. And then our size is going to be a bit larger, so almost out to Venus compared to where it is now. And then we're going to shrink down and have a helium core fusion. And then we're going to turn into a red supergiant. So we'll have a helium shell fusion. And our size of our sun is going to be out to our Earth's orbit. So Earth will be gone at this point. Then we will have a planetary nebula. This is made out of gas. And our star's outer layers are going to puff off. So that helium and hydrogen shell. Our white dwarf star is going to be made of carbon and oxygen, and our size is going to be about the size of Earth. And then we turn into a black dwarf here, where it gives off no light. For our big and our huge stars, we're going to see our big and huge stars. Our lifetime for our big stars is about 15 million years, where lifetime for our huge stars is about 3. We're going to see fusion of hydrogen, helium, carbon, and oxygen, ultimately resulting in this iron core. Then we're going to see a bright supergiant, so it's going to be as large as our sun going out to Jupiter's orbit or bigger. We're going to see this supernova explosion. So our star is going to collapse, rebound, and then explode. Our big stars are going to turn into neutron stars made up of neutrons, other stuff. It's going to be about very small, remember, about the size of Chicago compared to other stars. And then our huge stars here turn into black holes. So the gravity is so strong that light cannot escape these as black holes, which causes it this heavy gravity right there. Okay. So this is where we're going to end here. Remember, if you have questions, make sure you come to me and we will find those answers for you. Okay? See you soon.